Hi, welcome to OpenLC Solutions. Today we're continuing through the 2014 Ordinary Level Paper 1 and dealing with question 8. Now this question is all about area and volume, but you're actually going to need a little bit of calculus to solve some of the problems here as well. The very first one though, all it asks is to find the area of a square sheet of cardboard whose length is 12 centimeters. So the area of a square is given by the length squared. So that's 12 squared, and that is 144 square centimeters. And don't forget to throw in your units at the end of these questions. Part B gives you the square sheet of cardboard from part A, but the corners have been cut out of it. And with that, they're able to then fold up the sides of this new shape that's been formed to make a box. Now we don't know how big of a corner has been cut out of this. All we're told is that it's size h. And we're asked to write the length and the width of the box in terms of h. So let's say we take the length first. Let's say the length is the vertical one. So this is the length. And that's 12 centimeters. But it's missing a little bit here of size h, and it's missing a little bit down at the bottom here that also has size h. So the remaining length is 12 centimeters minus these two h's that have been cut out. And you can show actually that the width follows exactly the same formula. You start with 12 and you take away two of these squares, and so you're taking away two length h's from the width of the resulting box. Part C asks us to show the volume of the box is this particular formula, 4h cubed minus 48h squared plus 144h. And to be able to do this, you need to know how to find the volume of the box. That is given by the length times the width times the height. Now we know all of these. We don't know the exact numbers, but we have a way of representing them. We know the length is 12 minus 2h. The width is also 12 minus 2h. And the height is going to be h centimeters. So we multiply all of this out. I'm going to leave that h to the side for the moment. So I'm going to have 12 by 12 minus 2h. Minus 2h by 12 minus 2h, and then that's multiplied by a h at the end. I'm going to bring that in a bit later. For the moment, we get 144 minus 24h minus 24h plus 4h squared. Now I'm going to just clean that up a little bit. So I end up with 144 minus 48 h, combining the two h terms together, and a 4h squared. Now I get to multiply in that h at the end, and I'm going to rearrange it as well so it's in the form that we want, where we have 4h cubed at the beginning minus 48h squared and then 144h. So that's the volume of the box in terms of h. Part D asks us to find the value of h, which gives the maximum volume of the box. And hopefully you remember from calculus, the way to find the maximum of anything is to find the derivative and make it equal 0. So we have to find the derivative of the volume with respect to h, also known as dv dh, and we're going to set that equal to 0. So the derivative is going to be 12h squared minus 48 times 2 will be 96h plus 144, and that equals 0. Now these are very difficult numbers to deal with, so I'm going to divide everything by 12 to make it a little bit easier. So h squared, 12 goes into 96 8 times, so it's minus 8h, and 12 goes into 144 12 times, so that equals 0. Then to find h, we have to factorize this, so we go factors of 12 add to 8 are going to be 6 and 2, and they're both going to have to be minuses, so that equals 0. And so we have two options. One case is where h minus 6 equals 0, in which case h equals 6. The alternative is where h minus 2 equals 0, the other item in this product, in which case h has to be 2. These are both centimeters. Now the question asks us for a single value. They will pretty much always tell you when you're supposed to have more than one answer. They'll tell you values with an S rather than value. So we have to eliminate one of these somehow. And the way we do that is we have to look at the original dimensions of the box and say, is there some reason that this box can't exist with the given measurements? Or is it possible that maybe one of these will give the minimum volume? Because remember, maximum, minimum, you find them pretty much the same way. So in this case, we actually eliminate h is 6 centimeters. Because remember, the original square, let me draw a square. The original square is 12 centimeters wide. And you're cutting away the corners to the size of h. So if you cut away a square of size 6 centimeters from every corner, then you're actually just getting rid of the box entirely. So h can't be 6 centimeters. That's too big. And so the answer, of course, is h is 2 centimeters, because that leaves us with a box that can actually exist. Just as a side note, another sort of common way to rule out answers is if you have, say, a negative value for h. There could also be a case where h turns out to be longer than 12, or it might end up being 0. And so none of those cases can form boxes out of the original shape. Lastly, we have to actually find the volume of the box. So we have to use our volume formula, which remember is a function of h, depends on h. So we've got 4h cubed minus 48h squared plus 144h. And now we worked out that h was 2 to get the maximum volume, so you just have to put that in. 48, that'll be 2 squared plus 144 times 2. That's 4 by 8 minus 48 by 4. And this is going to be 288 when you multiply that. So that's 32. This will be minus 192 plus 288. And that gives us 128 centimeters cubed. Again, don't forget your units with these types of questions, because they will deduct a mark from you. So there you go, there's the maximum volume of the box. Thank you very much for watching, and hopefully I'll talk to you again in the next episode.